Okay, ladies and gentlemen, today we're going to take a look at our next topic. The topic is weathering, erosion, and deposition. It's actually two different topics that we're going to combine into one. They pretty much belong together, though. So, first thing we have to ask ourselves is, today we're going to look at just weathering. So, what is weathering? Well, think about it. If you leave anything outside and expose it to the weather, what's going to happen to it? If you leave it out there for a long time, is it going to look the same as it did when you first put it out there? No, of course not. So weathering is going to be the breaking down of rocks or any material. Now, weathering occurs when rocks are exposed to essentially three major things. The first thing is the air, right? So if you picture, let's say, leaving a bunch of rocks outside, right, and they're picked up by the wind and thrown all around, bumping into other things, if you find those same rocks again, are they going to look the same? No, they're going to be broken down into smaller pieces. Next, we have water. If you've ever been to the beach before, you know exactly what I'm talking about. Go to the beach and you can see that as you walk in different parts of the beach, the sand doesn't feel the same. The sand is going to be softest and smallest near the water, and as you walk farther away, let's say closer to the parking lot, those rocks actually get bigger and bigger and bigger. Water is going to break down or weather rocks. And the final thing, and this is one of the ones that we always tend to forget, is the actions of living things, meaning us. You're walking around outside, right? And you hear this kind of scratching every time you take a step. You look down, you have a rock stuck in your shoe. What did you do? Every single time you took a step, you were grinding that rock into your foot and into the ground. Do you think that rock is going to be the same with every step you take? No, you're going to slowly break it down. Okay, and this is a really good example of weathering. This is a mine, and you can see that this is a giant dump truck taking out some of the rocks that have been broken apart here, so we have access to different ores that we need out of the ground. For example, iron, aluminum, coal, things like that. So on to the types of weathering. There are two major types of weathering. The first one is going to be chemical weathering. Now, whenever we think of chemical weathering is going to be a form of breaking down the rock, but now we're going to affect the minerals or the chemical composition of the rock, meaning not the physical form of it, but chemical, what it's actually made of, that composition. So how do we do that? Well, this is an example of a rock. See all these holes in it? These holes were made by a chemical reaction. So the first type of chemical weathering is oxidation. Some of you might have heard of oxidation. Oxidation is more commonly referred to as rust. Now, what does that mean? Well, you get a bike. Your bike is made of metal, which a lot of rocks have metal in it, and you leave your bike outside in the rain and exposed to the air, and after a couple days or so, you get rust developing. That is known as oxidation. Okay, the iron that is in your bike is going to combine with the oxygen that's in the air, and it's going to form iron oxide. Now, we haven't looked at rocks yet, but iron oxide is going to be the mineral hematite. Okay, we will see that, and here is an example of rust. We see it more commonly in something like this. This was a farm tractor, and you can see that because it has been left outside and exposed to the elements, it is very clearly oxidized all over. Next, we have water. Right? Water is what is known as a universal solvent. Minerals are going to dissolve in water. In fact, a lot of things will dissolve in water. So water, if it rains really, really hard, is going to absorb some of those particles, have them dissolve inside of it, and those particles are going to be changed, hence breaking them down, chemically weathering them. This is an example of a home that was made out of earth, soil, and when it rains really hard and left exposed over time, it's going to slowly break down. Acid. This one is cool to see, which I will demonstrate when we take a look at the rocks and minerals, but it is a little bit dangerous in our environment. Carbonic acid. We've all seen this. You've opened up a bottle of soda before and you get those bubbles. That's carbonic acid inside of the soda, right? That is essentially coming out. So the carbon dioxide is dissolved in rainwater, right? And it forms a very weak acid, right? So again, we see it in soda or Alka-Seltzer or anything that if you've ever put, especially now, if you dropped the Emergen-C in water, you get those bubbles. But it can also be stronger acids, right? If you take sulfur dioxide, which is a very common automobile pollutant, right, or truck pollutant, it's going to form a much stronger acid, and it can completely break down different things, buildings, metal substances, all right, and it can cause really bad burns, as we can see here in this picture on the left. Okay, so when we think about it, there are going to be two different rocks, limestone and marble. And again, I know we haven't looked at the rocks yet, but we will. All right, that will most easily break down by the acid test or the acid rain. All right, and as we can see here, this is an example of a gravestone. This gravestone is not very clear anymore because it has been exposed to acid rain and the materials have slowly broken down. Very, very common. So here are a whole bunch of chemically weathered gravestones. Some are going to be more severe than other based on the type of material. Older gravestones were made out of limestone and marble because they were less expensive. Newer ones tend to be made out of a much harder rock, granite, which is not as susceptible to the acid rain and chemical weathering. Next, we have physical weathering. Okay, physical now is where we're going to physically affect the rocks themselves. So when we think of physical weathering, this is going to be taking those rocks, breaking them down into smaller pieces without some sort of chemical change. So we're going to physically break the rocks. So what can physically break the rocks? First is going to be frost action. It's also known as ice wedging. Now, this is something that you all are familiar with, especially this part here, wedging, right? I know usually when we are in class, this is something that usually makes everybody laugh and giggle, but ask yourself, what is a wedgie? Everybody knows what a wedgie is, right? When you're sitting in class or walking around and your underwear slowly wedges itself into your butt crack, right? And what that does is it splits apart your two cheeks. That is a wedgie. In nature, water has that same ability. So water is going to seep into all of the small cracks in the rocks themselves. Then, now water does this when it freezes. When the water freezes, it's going to expand. Put a water bottle in the freezer, when you take it out, it's kind of blown up. So when that water expands, the crack is going to get much bigger, right? It's going to widen, right? And then as the sun comes out the next day, the water is going to melt. And what happens is the water then seeps even deeper and deeper and deeper into the crack. So we see this all the time with our streets. So summertime, pave over the street, nice smooth street. Right? Then winter comes around, the first little bit of water gets in, creates a crack. Next, right, it's thawed out, the water seeps even deeper. Now, later on, water freezes again, makes the crack bigger and bigger, and over time, if we take a look at this picture here, over time, all these cracks are going to slowly and slowly get bigger and bigger. Think about it. In the springtime, after we've had, especially a really bad winter, the roads are terrible. Lots of holes, lots of cracks, things like that. Okay, so rocks, boulders, massive, massive things are split apart by frost action. All right, so again, we could see it here, right? Slowly splitting apart the rock, breaking it into smaller pieces, physical weathering. Okay, this large rock right here used to be stuck on the side of the mountain there. It's not there anymore because the water seeped into all the cracks here and eventually cracked it and made it fall off. That's frost action. Right? Next, we have exfoliation. Right? Exfoliation is where we remove the outer layers of rocks. Sometimes you do this to your skin when you wash your face and your soap has kind of that gritty feeling to it. You are exfoliating, removing the outer dead skin cells. So exfoliation usually occurs, right, when rocks are deep underground. There's lots and lots of high pressure, okay? When that pressure releases, the rocks are going to expand and they're going to crack, and the outer layers kind of peel off. So you need heating and cooling. The rocks expand and contract. All right, this is an exfoliated rock. We can see that this outer part here is missing. Lastly, we have abrasion. Okay, now what is abrasion? Take a look at all of these rocks that are down here. Right? What is similar about all of them? They all have this rounded shape to it. Well, how does that happen? Well, when rocks are abraded, right, they are rounded because they are rubbed together. So what happens? Right, it causes a very rounding shape, and it's generally carried by water, right, running water, and sometimes even wind. All right. Rocks are picked up in water, carried around, and every time that they roll on the bottom of the stream or river or ocean, or they're carried by the wind and bump into the ground, the parts that stick out are going to break off. Now, an example I would use in class, let's say I jumped into a fast-moving river. Okay, my arms and legs and head are sticking out, and I'm kind of flailing all over the place trying to call for help. Every time I bump into the bottom, what happens? Well, first time I bump in, an arm gets broken. Next, legs. Next, another arm. Next, my other leg. Finally, my head. I know it's a little gruesome, but the only thing that is then left of me is that kind of rounded middle part. So if you have a person, right, there's the head, arms, legs, all these things here stick out. And as the rock rolls along the bottom, those things that stick out break off until all you're left with is this nice rounded middle part, which is why all these rocks have this nice rounded shape. Okay. Now, lastly, how do we influence the rates of weathering? The first thing, and this is probably the most important and the most difficult to understand, right, is going to be the surface area exposed. So, weathering can only occur on the part of the rock that is exposed, meaning just the surface. Okay, so the more surface is exposed, the faster the weathering that'll occur. Now, I'll explain this diagram in a moment, but I want you to think about sugar, right? If you're making a drink, right, there's a reason why sugar comes in a granular form, meaning those small little particles. When you put them in, let's say coffee or tea, or you're making Kool-Aid and you mix it up, those small particles disappear. But let's say you get a big clump. That big clump doesn't disappear right away. It won't dissolve. You have to break it up into smaller pieces. And the reason for that is because there's less surface area. So let's take a look at this mathematically. First, all of these blocks down here are all the same overall size. So this is the same size as this, is the same size as this. But if we take measurements, we only can get exposed to the outer parts here. So this is 2 units, this is 2 units. Get the surface area, 4 square units. So now down here we have 4 square units, and since it's a cube, there's 6 sides, and there's only 1 cube, 24 square units. So there would only be weathering occurring on 24 units of space. Now, if we took this big block and cut it in half, 1, 2, 3 times, so 1, 2, 3 times, now we have 1, 2, 3, 4, 5, 6, 7, 8 smaller cubes. So we have 8 smaller cubes. Again, each cube has 6 sides, but now instead of the 4 square units, each cube has 1 square unit. But when we do the math, 1 times 6 times 8 is now 48. So by cutting these into smaller pieces, we've got even more surface area exposed. So now, instead of the middle here, which water can't get to, water can get everywhere around these cubes. And we do it again. cut everything in half, just like we did this first one. Now, the overall size of the cube is smaller, so now we have 0.25 square units. Again, each cube has 6 sides, but now in this image, there are now 64 cubes. So now we've got 96 square units. So this is like the spoonful of sugar you drop in. This is like that big chunk. This one here is going to break down and weather much quicker because of that surface area. Right? The mineral composition, again, I know we haven't talked about minerals, but some minerals are just going to be more resistant, meaning harder than others. For example, quartz is resistant to both chemical and physical weathering, whereas what I mentioned earlier, limestone is not as weather resistant. So when we look at this, you can see that this area right in here, see how it has that big hole? Well, it has that big hole because this rock has to be less resistant than these other ones would be. And finally, we have climate conditions. So climate, remember, long-term weather. So when we have a cold or a wet climate, it's going to favor physical weathering. When we have a warm and wet climate, this is going to be more chemical weathering. Right? And then frost action, you need the temperature to change, right, at a fairly regular rate, meaning cold at different times, warm at different times. Okay. Now, why would physical weathering be favored by cold and wet climates? Well, this is where you get that frost action, right? You need the water and the cold. So during the day, the temperature gets a little bit warmer, melts that ice, water is going to seep into the cracks, split that rock apart. Warm and wet climates favor chemical weathering, acid rain. Water is going to dissolve minerals more easily. Oxidation, meaning rust, is much more common here. Okay, so this chart is something that is not in our reference tables. Again, it is not in our reference tables, but it's something that's worth taking a look at. You have your temperature here on the bottom, right? And then on the side, you have your average yearly precipitation, meaning the amount of rain. So you could see the more rain you have and the warmer the temperatures, you get more chemical weathering. The colder the temperatures, but you still need water, right? The more water, you get more frost action. Less water, you only have a little bit of frost action. Okay, and when you have warm temperatures and no rain, you don't get much weathering at all. So things tend to stand up and last for a long time. Okay, again, this is a graph that we are most likely going to be taking a look at a later time, and you might see it with questions, and all you'll have to do is identify the type of weathering that is most likely going to occur. Okay, now this is where we're going to stop for weathering. Okay, at this point, you'll go on and you'll answer the CASA learning questions that are associated with this part of the notes.